Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Your host is Tobias Macey, and today I'm interviewing Junping Du about Gravitino, an open source metadata service for a unified view of all of your schemas. So, Junping, can you start by introducing yourself?
Thanks, Tobias. Yeah, this is Junping Du, and I have over 15 years working on the open source and data industry. So I served for companies such as VMware, Hortonworks, Tencent. I used to be a Hadoop guy, a long-term contributor, committer, and also the release manager of Hadoop. So I'm a super fan of open source technologies, especially for the data and AI area. So now we're building a startup, a new company called Data Strato that starts in 2023. And Gravitino is open source data catalog is our main focus to break down all the kind of data silos because of different data lakes or cloud vendors or separation of data and AI in software stack. We try to break down all kinds, this kind of the data silos.
And do you remember how you first got started working in data?
Oh, I still remember. So that's over 13 or 14 years ago when I started to look at what Hadoop going work when I'm still in VMware. I was thinking about that's great. In VMware we are doing something like a virtualization, but now a lot of data stored here together with with thousands of machines can work together. It's fantastic. VMware tried to break the big machine to pieces, but Hadoop tried to merge a lot of data or engine or machines into a big giant machines. I was thinking it's a very cool technology. I tried to combine these two technology into together. So that's why I start the vHadoop at that time. That's internal project for VMware to how to launch or run Hadoop very efficient and scalable in VMware virtualized technology. That's a start for I'm from the cloud technology to the data technology.
Now, digging more into Gravitino, I'm wondering if you can give a bit of an overview about what it is and some of the story behind how it came to be and why you decided that it was worth your time and energy to invest in building this technology.
Of course. So for as I mentioned, I have been working on Hadoop technology for a long time, and afterwards I working on some cloud data warehousing and data cloud data lakes building. So I definitely we find several interesting findings. So first is the data silo problem. That not only means data is siloed by different database, data warehouse, and also it is sometimes siloed for multi-cloud, hybrid cloud scenarios. And also we will notice that the revolution of generative AI really created new patterns for accessing the data, especially for unstructured data. So previously, structured data is more like structured and the plan, so we can do a lot of data preparation ahead. But for now, there's more data accessing. It's ad hoc and on demand. And third, we find the problem is data technology is growing actually a little bit slower, or behind of how the GPU power going, how the large language model technology is going. So it will definitely make the data as a bottleneck in this kind of large language model revolution. So we want join the efforts to accelerate it. So we think Gravitino will be serving as it's just like a Tesla time for the data platform technology, right? So the autopilot is over faster engines. I think data platform is in the same stage now. So so we ask ourselves, what is the intelligent about the data? I believe any data engineers, data guys will think it should be metadata, right? It has all the knowledge about data. So that's why we try to building a metadata lake. No matter its data is for transactional database and analytics or the AI workloads, we try to building a metadata lake that is Gravitino.
You mentioned the metadata catalogs that are in use right now for different query engines for tabular data. You also mentioned the application of Gravitino to unstructured data sources for use in more AI-oriented workloads. And I'm wondering if you can talk to some of the ways that you think about the expansion of that metadata store beyond just the tabular structures and beyond the constraints of a single database
Yeah.
engine or query engine.
Yeah, I can take the example, rather than the tabular data, you manage all things with tables, right? Table schemas. And now we are supporting the file set management, that kind of the data set management. So basically, if your PyTorch, your array want to consume some data sources from some data sets, so we can manage this. We can directly serving, PyTorch array directly. You can read it here. And with this, we can managing structured, unstructured in the same place. And then the data engineers will know, how the AI team or AI engineers consume this kind of data. They can do access control. They can do monitoring of, how AI team is using this kind of data. They can know, okay, some of the unstructured data is not useful anymore because no models, consume it anymore. So they can do a better, cost saving and data quality monitoring, something like that.
And I'm definitely interested in digging more into some of the specifics about how to populate and how to make use of that metadata for unstructured storage. But before we get too deep in the weeds on that direction, I also want to talk a bit more about some of the problems that you are looking to solve with Gravitino and some of the ways that you have seen teams address those problems in the absence of Gravitino.
Yeah. So Gravitino, just like I mentioned, we try to unify the different data formats and sources in, with different data AI engines. So we create a new layer. We call it the modern open data catalog. Yeah, it's I think the same concept as a data fabric. So with this kind of open data catalog, built by Gravitino, no matter what kind of data, lives somewhere, which cloud it lives, on what kind of format it's using, it's a Hive tables or it's iceberg table or it's some vector database vector store. We can use a mainstream, data engine or AI engine to access it, no matter not only just read, but also to write, update, append, whatever it is. I think this is we try to building solving the problem with the Gravitino. So previously, a lot of engines on data products try to building the vertical stack for data, but we are more like to building a layer to serving different verticals, so that break down the silos, right, for access pattern of the data.
In the category of tabular structures, one of the longest running projects out there, at least for the case where you're not using a specific database engine, is the Hive Metastore that was intended to address this cloud data lake or Hadoop style architecture where you have lots of files everywhere, you have different table schemas or table formats, and so the Hive Metastore was used as a means of being able to keep track of all of them, and it had different methods of populating that metadata, whether it's from Spark or from data crawlers or from API calls. And I'm wondering what you see as the reason that that was such a lasting technology that stuck around long after Hive started to fade away, and some of the opportunities that you see for innovation in that metadata layer for being able to improve the overall experience around how to interact with these different data systems.
Yeah, so traditional, I mean, high metastore really lasted for quite a long time. It's becoming a de facto standard for industry for a very long time since, Hive appears maybe more than 10 years ago. It's lasting there because, a lot of engines is trying to using high metastore to store all the metadata on top of that. But things have changed. I mean, a few years until now, as the more modern data engines try to building their metadata or catalog itself, such as ClickHouse, such as StarRocks, or some new engines, and also HighMetStore cannot managing the AI capabilities, such as unstructured data directly. It doesn't can manage it directly. That's a reason, because HMS is not a growing fast community. It's not solving the problem we're facing today. So end up with, we either join the Hive community to building something new with a lot of legacy code or system, or we can start some new project with inherit some capability from the HMS, but actually extend it to something brand new features and product. So we choose the later one. We choose Gravitino, try to building this new product that can compatible with HMS. I think that's also the logic for some maybe other product is try to build in the heading two is try to compatible with HMS, but we're building something new. This is because the new requirement driven and also a lot of a long history of legacy that HMS already formed. We have to consider this kind of standard or follow.
In that general theme of Hive, where it started off as a query engine, it brought along the metastore as a means of keeping track of the different table metadata. Looking at the documentation for Gravitino, it seems that it is also doing a few different things at once, where it has the metadata storage for being able to keep track of tabular and unstructured data so that you know where it lives. You have some capability for data federation for being able to query across these different data sources, similar to Trino or Alluxio. And it also acts as a way to do some measure of discovery of data in the vein of an open metadata or an Atlan. And I'm wondering if you can just talk to some of the ways that you think about how Gravitino overlaps with some of those different areas of functionality and some of the ways that you think about how it can either supplement or potentially even replace various technologies in different use cases.
Yeah, I think that's good question. So we do have some overlap with existing categories. Take have Metastore for example. Just like I mentioned, we have Gravitino today has a wrapper of HMS. That is way we don't have to replace it. Instead, we manage it and upgrade it with the new capabilities. Right, it's very important as HMS serving as quite important component in the open source world for a long time. So we can be compatible with first and replace it later when after user feel more comfortable. About the metadata repository part, the open metadata is more like a traditional data governance tools that I can copy metadata from one place to another and do some access control and some other data lineage work. But it cannot serve computing engine directly. It's different scenarios with Gravitino. About data federation, actually we're supporting the Trino. We don't do data federation directly, but we support the engines such as Trino, such as Spark, can do the federated query over the multiple high meta stores or multiple data catalogs that can cross different cloud or different data lakes, which is a super cool technology on top of that.
And as you are building Gravitino, as it has some of these different capabilities, there's always the challenge of scope creep, where you say, oh, it'd be really neat if it could do this thing over here. And then you start to expand the range of things that it can do, which increases the overall load for maintenance and the complexity of the project. And I'm curious how you're thinking about what to explicitly keep out of scope for Gravitino and the things that you definitely don't want it to grow into.
Yeah, thanks. I think that's also a good question. And always, so we are serving as a unified metadata center, right? So that means our scope is big enough. We don't want to grow the scope to be something like a query engine. We don't want to be a query engine project, right? To serve the optimization for some dedicated query engine. So we treat the Spark, Trino, Streamio, ClickHouse, whatever computing engine we support equally important. I think this is very important and unique value for us comparing with other a new catalog that's supported by one query engine vendors. I think that's a fairly important.
In terms of the technical implementation, I'm wondering if you can give a bit of an overview of the architectural components of Gravitino and some of the ways that you thought about the design and implementation of it and in order to achieve the goals that you set out with.
Yeah. So in high-level scene, the Gravitino has layers of architecture, right? The core layer is abstraction of the catalog layer, which could support database catalog, file set catalog, which is dataset, right? And also streaming catalog, which support Kafka and other streaming engines, and also the model catalog, which is support the managing of the AI models. So this is we can support more catalog types in the future on demand, but currently this is pretty wired enough to support the mainstream scenarios that we finding in the community. So underneath is a connection layer which connect with different data sources, such as file set, such as tabular data, such like streaming data, right? And on top of the core layer, it has interface layer, which interface it actually support the RESTful interface, JDBC interface, and potentially a Swift interface as well, which is useful to different computing engines to using Gravitino. And that's these three layers is the core of Gravitino. And the most top layer is a functionality layer, which can providing some data management and data governance layer, such as access control, data lineage, data quality, extra. So that is typically the technical architecture for Gravitino. So we start to work on it in the beginning when we before we start the company. We think the most important thing is figure out what to do instead of how to do it. So we discuss a lot and decide to go with to building the metadata lake first, because there's no reason for the world to have additional data engine, query engine, no matter query engine or computing engine, too much engines, right? And which is important to have a single layer of the metadata, right? To make the different engines can work with different data sources. So that's make the core design, the data models is very important. How to abstract the models for different type of the engines, different type of data, especially the structured data there and the unstructured there, how to abstract it. So we do very carefully and flexible design, and it can be continue to evolving to today's, so we can support different way of data manipulating or data computing. So that is the core part.
As far as the role of Gravitino in an overarching data platform architecture, I'm curious if you can talk to the process of integrating it into an existing set of systems, some of the types of technologies that you would want to layer on top of Gravitino to be able to take advantage of the information that it holds, and also maybe some of the ways that you're using Gravitino in your own work at Data Strato.
Yeah, of course. Data Strato, we are building the Gravitino is it's a first product, and now is our main focus on top of that. And to launch the Gravitino is definitely a platform service. It can run separately, but it can easily to integrate into this mainstream open data architecture seamlessly, right? It can support Spark, and support Flink, Trino, Doris, Table, and the traditional Hive tables, right? So if you have a legacy system, keep it going, and when you launch the Gravitino, you were very surprisingly to find it can work with a lot of your existing components very well, and it can merge a different metadata view into a same single metadata view, and your engines can go through Gravitino to query or to do the computing on the some data stores or the data sources that previously you cannot attach to it. So this is a quite interesting journey when we find it from the community, a lot of community users and customers to give us a feedback.
Once a team has integrated Gravitino into their architecture, they're starting to use it to store metadata, populate metadata, query metadata. I'm wondering if you can talk to some of the ways that they might interact with Gravitino in a typical workday and how it fits into the overall workflow of being able to use the underlying data that Gravitino points to.
Yeah. So previously, if you're using the Hive Metastore for a long time, it's over almost seamlessly as a previous experience. Like you Spark job, your trainer job is continue to work with previous data sources, which is fine. And if you were like data engineers to work on some ETL, right, to merge different multiple tables from different places to be a single table, and after that you can do some additional work, for your data pipeline. You will find it's Gravitino very powerful because some of the unnecessary ETL can be skipped. So we can using Gravitino, you can know all the table there and try to building your final table from the skip some mid table to be a final table. So this is definitely the change. Additional because we are building the centralized metadata lake, so all the access pattern for your data pipeline, and you know how your metadata or data is accessed in different ways. So you can put some monitoring on that. You can know, okay, some of the table, especially for the middle table, is not needed anymore because no data pipeline is actually using. You can delete it or you can drop it. You can do more fine-grained data, the lifecycle management on top of that.
And now, in terms of the unstructured data flow, tabular data is fairly well understood. Lots of different tools interact with it and interoperate with it. Unstructured data has been around for a long time. People have different solutions, but it has continually been a challenge to work through. And I'm wondering if you can talk to some of the ways that Gravitino helps to address some of those challenges and the workflow for being able to locate and catalog and interact with that unstructured data and managing the organization of those unstructured sources.
Of course. So it has been a long history for structured data to be managing, because we have, more than many years experience how managing this kind of data, right? And for unstructured data, it's quite a new thing. I mean, previously we using ETL to make the unstructured data to be structured data, right? This is what Hadoop age doing over 10 years. But today, a lot of AI models actually they want to go directly with unstructured data, right? To go to the AI model to consume it in a in the consuming various ways. So that make the requirement for managing the unstructured data it's more hard to achieve. So previously, it just managing unstructured data in with S3 link or some storage place link is definitely not enough. So the first things we need a centralized governance, right, for unstructured data. So who can access it? And this is number one. And number two, do we put some more rich for metadata info just rather than a link, right? Do we have a description on what kind of unstructured data it is and how to use it and how to turn it into to consume by your models or the feature stores. I think this is number two. Number three is how to make your structured and unstructured data to work together. Sometimes this is not only unstructured data is not only on the training stage, right? Sometimes it's useful on your rack building system. You will leverage your unstructured data to give you some answer, right, to your questions when you give into the large language model. So you need a centralized way to managing both structured and unstructured data to make them work together. So that's typically, three cases we can think from today's requirement.
Earlier, you also mentioned being able to have some insight into whether a model or engine is actually accessing some of that underlying data to determine how long you want to keep it around for, or whether you can cull that data to save on storage or cost. And I'm wondering some of the different access data that you are able to use and provide insights to the end user as far as what data is valuable, what data is just taking up space and cost, and some of the higher order workflows that people are able to build from that visibility.
Of course, I think that's important, and some of the community user already leverage these features. So they definitely using the file set to manage their unstructured data, and definitely find the access pattern for their AI team, how to consume this data and in which kind of frequency. And based on this statistics, they were using different backend storage, right? They have tiered backend storage. Some storage for hot data, some storage for warm data, some storage for cold data. So they can move the most frequency access the data to be hot data. But some of the non-active access for the unstructured data is moved to the cold data, which is saving a lot of cost for this kind of unstructured data revolution. So this is definitely a showcase so how we leverage these features to achieve the fine-grained management on unstructured data.
Another piece that you touched on briefly is the governance of that underlying data. And when I was looking at Gravitino, it mentions having a centralized access control capability. And I'm curious if you can talk to some of the permissions management and some of the ways that that feeds into some of the other systems that are relying on Gravitino, and just some of the overall challenges of managing some of that permissions and access control across different layers of the data stack.
Yeah, that's fairly the pain point before, right? You have to work on different data engines and set up these permission access control settings. So Gravitino is trying to solving that in the more unified way. So the design of the Gravitino is we have different authentication and authorization workflow, right? And through authorization, we can work with different underlayer platforms, such as Hadoop ecosystem. It's maybe using Kerberos, right? For the some cloud engines, BigQuery or Snowflake, they're definitely using some IAM related mechanism. So we work with this different kind of mechanism, and so that the token we take, the Gravitino can take, can be using in different underlayer system. So this is typically the high-level design principles. So with the unified centralized permission management, so customer don't have to be setting this kind of access control in different places. You can set directly in the Gravitino, and after that, this permission for file set management or table management or even fine-grained row-level access control, it can be support and be set into the underlayer system. So we're not storage layer, right? But we can help to set the storage layer access control. So this is the design principle for us.
As you have been building Gravitino, using it in your own use cases, helping to support other people who are adopting it, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
That's interesting because previously we want to build in some very generic catalog support, right? We support JDBC, we support REST catalog in general, but eventually, community users asking, okay, can you building something like a data lake format catalog, such as Iceberg catalog, such as Hoodie catalog. So that's why about half a year ago, we start building the Iceberg REST catalog, integrate the capability into the Gravitino, and we support it. So now you can see 2 or 3 other open source data catalog can support Iceberg REST catalog. But this is we do it first, and this is because the community user is asking for it. I think with the community continue to growing, we'll find more and more scenarios that Gravitino can potentially address. Just to follow the community users' needs, and we will definitely finding something new and interest to follow.
And in your own experience of building this project, working with the community, building this business that relies on Gravitino, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Yeah, so I think initially we tried to totally replace HMS, to be honest. So we think the HMS is lasting for too long time, just you said, right? But after we do that, we have a very early stage initial version, but a lot of community users say, "Hey, we want you to compatible with HMS because we're using it for quite a long time. We may retire it in someday, but not now. So can you work with us?" So this is something unexpected, but we respect what communities request or required. I think this important lesson, and also a lot of lessons we learn from it among the AI part. We don't realize because the file set management stuff is it's not a very complicated technology, right? But with this kind of adding features, we're finding a lot of users is really interesting on this feature, and really they're suffering a long-term pain point from that. So I think this is something quite interesting as well.
For people who are looking to either expand or improve their experience of catalog management, what are the cases where Gravitino is the wrong choice?
Yeah, so if they have very limited data sources, and this scenario is very simple, like they just have one data engine and maybe on top of the one cloud. I think they don't have to use in Gravitino, right? And if there's no AI workload involved, just the pure data analytics or data engineer stuff, I think there's no governance required. I think Gravitino may not very useful in this case. It doesn't harmful that definitely, right? But it's not very useful.
And as you continue to build and evolve and improve on Gravitino, what are some of the things that you have planned for the near to medium term, or any particular projects or problem areas or features that you're excited to dig into?
Yeah, so we try to continue to building more AI capability on top of that, especially if we are adding more features towards unstructured and management, including the lineage, right? So unstructured and models, how to make this, so from the unstructured to feature stores features, and to be models, this kind of lineage capability. We will try to building a lot of more governance lineage capability, including the data, maybe data sharing in some timing for to make the Gravitino more useful in a lot of kind of cases. We really think in the future. I mean, when I just mentioned, data could be a bottleneck for this kind of AI revolution. And then what that means? That means is we're lacking of enough data, and we lack of enough high quality of data. So that's part of the Gravitino's mission is we try to unify all the possible accessible data, right, to make it more accessible. And also we monitor all the data, the quality to make it more increase the visibility of quality of the data, no matter it's structured or unstructured. I think this mission is quite important to Gravitino, and also this is part of the very important reasons why Apache. That's why we try to donate to Apache, becoming Apache Open Governance Project, because we want it to be open. We want to be addressing the real data challenge in the AI time.
Are there any other aspects of the Gravitino project, the overall space of catalog, metadata, unstructured data management, the ways that AI workflows are evolving the needs for data cataloging that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think we discussed a lot on this kind of stuff. We may discuss later in the future if we have made more progress.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think definitely it's the data guys doesn't know AI too much. The AI guy, doesn't lack of the data background or perspective. It's today's big, I would say, big gap. So we try to be a unified layer to not only the product to different technologies, but actually to unify the data engineer and the AI engineers, try to make the two team can understand each other. Unless they're using the single data platform or data tools, they can understand each other. If they can continue using different tools, how can these two group of guys to know each other? So this is our mission. I think is also our dream to do that.
Absolutely. Yeah, there's definitely a lot of incidental complexity that is coming up as a result of the increased usage of AI and machine learning, and the fact that the technology stacks are being built independently and in isolation of each other. There hasn't been a lot of bridging that has happened yet.
Of course. Yeah.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on Gravitino. It's definitely a very interesting project. It's great to see more innovation and investment in this space of cataloging because, as we noted before, it has been stagnating for far too long. So it's great to see you out there helping to push the space forward. So thank you again for your time, and I hope you enjoy the rest of your day.
Yeah, thanks. Thanks, Tobias. A very good conversation with you, and wish you have a good one. Thank you.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.